So good evening everyone. So we are the future hackers and my name is Kusumanjali Shetty and he's Adhert Johnson and the other teammate is Laxman. And so we took a case one, and it's predictive AI for housing displacement risk in Jacksonville and peer cities. So coming to the motivation and the problem statement, our project focuses on predicting housing displacement risk, which means identifying areas where people are most at risk of losing their homes because of rising rents or other economic pressures. And this is most important because many affordable housing units are expected to expire or disappear in next few years, like over than thousands of them. Local governments doesn't have good early warning systems to spot their risk. So we chose Jacksonville because it's growing quickly, and some neighborhoods are becoming more expensive, and because of that a few people are like moving out of it, and because of the low income families and all. So we wanted to understand not just where the risk is high, but also why it is happening. And coming to the solution summary, to solve this problem we built a AI model, and the model is to measure the risk of housing displacement for every neighborhood and to compare Jacksonville's trends with 19 other US cities. We used more than 150 public data sets from sources like HUD, USDA and mySideWalk. And the system automatically cleans and prepares data, finds important features and makes predictions. And on the right side you can see the outputs and the risk map which was provided. We'll be talking about that in the end of the presentation. And coming to the data description and APIs, our data we took our data from the several sources, mainly housing and demographic data sets. We used information on federally assisted housing programs like HUD, plus data on rent, income and overcrowding. And in total, we worked with around 150 CSV files, as I mentioned before, and 4,000 census tracts. We cleaned and standardized all the data using the census tract ID, and then we created a label for each area based on three key indicators, based upon the percentage of low income household that spent too much on rent, and percentage of overcrowded units, and percentage of households with no vehicle. These labels help the AI learn what high-risk neighborhoods look like. And about the bar chart which is present over there, that shows most of our housing data which we got. And as you can see, the biggest portions portions are from NHPD and HUD CHAS, which provided the largest number of housing indicators. Yeah. We also used data from US Census Bureau, and which added important information about income and rent. Other smaller sources like USDA and EPA gave us extra details about environment and community factors.
So the three models we used were logistic regression, random forest, and gradient boost. So in this, random forest had the best accuracy. So our predictive AI model achieved strong performance on real-world data. Using a leakage-free holdout test, the model reached an AUC of 0.796 with 78% accuracy and balanced precision and a recall for high-risk areas, both around 0.7. In simple terms, the model correctly identifies about 4 out of 5 neighborhoods that are truly at high displacement risk. This means our approach isn't just theoretical, it's reliably distinguishing stable versus vulnerable areas, giving city planners early actionable insight before displacement happens. So the random forest model uses socio-economic and housing indicators like rent, burden, income, subsidiary expiration, vehicle access, and overcrowding to predict which neighborhoods are most at risk of housing displacement. Our objective 1, we focused on understanding what drives displacement risk, not just predicting where it happens. Our analysis found that the strongest early warning indicator is rent as a percentage of income, showing plus 0.68 correlation with displacement. And other critical factors include high overcrowding, no vehicle households. Based on these patterns, we identified clear early warning thresholds like rent. Whenever the rent goes more than 40% of income, that's an early warning. Then the overcrowding more than 10%, then the SNAP dependence more than 15%.
Yeah. As my friend said, we use the same features for the objective 2, which is to compare Jacksonville with the other major cities in America. And here are our findings. We got the top 10 cities which are in high risk in the America with a high predicted risk percentage depending upon the tracks, and Jacksonville is in the bottom 10, which is like 11th place out of 19 where the index starts from 0. And the top most risk predicted city is Miami, whereas the lowest city is Oklahoma City. And this is the objective 3, where we have passed the model inputs to the policy insights and grouped the model outputs with the Jacksonville's 207 census tracts to get the geo IDs. And using this, we created a future map of the Jacksonville, dividing the map into different parts using the geo IDs and predicting the top 15 places of Jacksonville which are at the higher risk. We have colored the map with the darker color indicating the higher risk and lighter color indicating the lower risk. Here you can see the map of Jacksonville where south side is colored more red. So it's a kind of Bay Meadows area where more IT residents reside over there. It's marked more red, and the downtown city, where outskirts of the Jacksonville are dark light, so they are having high risk, low risk compared to other parts of Jacksonville. It gives a clear insight for the investors and policymakers to invest future in Jacksonville and make decisions. At the end, we have achieved to create a predictive AI model which takes raw housing data and gives the output as the partitions where it says input to the policymakers and insights to invest in the places. This is the output we got. It says the different geo IDs based on different geo IDs, and we got where the darker color indicates the more risk and lighter color indicates the less risk. The overall model accuracy achieved for this is 80%. Thank you.
I just have a quick question. I'll yell it. Is there a data set? Y'all had the three, the low income, overcrowded units, and households with no cars. Is there a data set you wish you could have had in this model that you considered but you couldn't find the data for?
We use 150 plus CSV files where some CSV files consist of the more null values. We omitted the data, and there are some other columns which have less number of null values where we fill the values with the most predicted median values and we group the data.
Okay, but was there any specific data that you personally wish you could have included in the model that you didn't have available? Just off the top of your head. No, not really? Okay, cool. Thank you.
So on the data, you listed on one of the slides that you have an automated way to clean and normalize the data. So did you develop something that actually could take that data and automate this? So if this was to put in production, it can automatically ingest data and then deal with the missing values?
Yeah, we deal with the missing values. Like first of all, we categorize all the data, and we got the ample amount of data. We can't run all the data on our RAM. Our RAM we need to restart the session, and we cannot further run the code. So we made the pipeline in the lighter version, like omitting the unwanted data, like the columns with most null values, omitting that kind of data, and if there are only some kind of null values, if we can still use them, and then we fill the values with the most predicted median values, and we consider the data. And the most considered features are like the overcrowded people in a family, and families spending 50% or more of the income on the rent, and people without vehicles in the home, and expiring subsidies.
But did you develop a system that automatically does that then for future
Yes,
data?
Yes.